Good morning, students. Today we will have the discussion there on very simple topic, that is demultiplexers. Now, what is a demultiplexer basically? As we all know, it is a combinational circuit that takes a single input line and send it to one of the output lines. So what it mean here, with a single input it will have multiple output lines. It is basically the reverse of the multiplexer. As we all know, when we are talking about the multiple lines and it is the reverse of multiplexer, then we should know that how many output lines it is going to use along with the number of select lines. So you can see here a demultiplexer basically has 2 raised to power n output lines with n number of select lines. So these select lines are basically used to select which output line to send the input. So that's why the demultiplexer is sometime, or it is also known as data distributor. So depending upon the status of select lines, it is going to send the given input, that is a single input, there to the respective output line. So output lines are multiple, input is single, and there are n number of select lines. So that we have to take care. Now second thing is how many types or what are different variations. What are the different variations we will have there for the multiplexers? So demultiplexers. So just like the multiplexer, we will have 1 by 2, 1 by 4, 1 by 8, or we can even design 1 by 16 demultiplexer. Now, when we talk about the 1 by 2, from the definition, we came to know that it is 1 by 2. 1 by 2 mean that there will be a single input and 2 output lines will be used. So 2 output line mean there, as we know the basic formula, that is 2 raised to power n. 2 raised to power n mean these are the output lines, number of output lines basically. So in this example, when we are talking about 1 by 2, the select line is the single one. So the value of n will be 1, and when we talk about this 2 raised to power n, it means the output lines will be 2. So that's why it is basically known as 1 by 2 demultiplexer. Now you can see here a 1 by 2 demultiplexer uses one select line to determine which one of the two outputs is routed from the input D. Now you can see here, this is the block diagram. This is a single input D. These are the two outputs, I0, let us say I1, and the single select line, that is S. So the next thing is, what will be the truth table depending upon this one select line, two output lines, and one input line. If we talk about the truth table of this 1 by 2, then it will be designed like this. The given select line is the single one. Let us say it is represented with symbol S. The two outputs, let us say they are represented as I0 and I1. So the single select line is going to give the status of output line selected. So you can see the S will have two possibilities, either 0 or 1. So let us take the first one 0 and the second possibility 1. So when the value of this select line is 0, then the given input as per this block diagram, you can see here we have taken D as a input. This input D will be directed to the output line I0. So with and the second one, because here the single input is going to be selected, single output line is going to be selected. So for this row, the second output line will be disabled. Similarly, when the value of select line is 1, then the output line selected will be I1 by keeping the second one, that is 0, or let us say disable. So this is the truth table with respect to this block diagram. So it is just a basic one, how we can design a 1 by 2 demultiplexer. Now if we talk about the logical expressions, so we can even write the logical expression with respect to these two very easily by following the truth table. So let me write it here. With respect to the first row, we will have S bar D. You can see here the output line with respect to this row will be I0, will be I0. Then following the second row, the output expression for I1 will be, like in this case, it can be written like this. So these are the two Boolean expressions which are with respect to this block diagram, where D is the input, S is the select line, and I0 and I1 are the symbols that represents the output line on which the given input is going to be connected or routed up depending upon the value of select line. So following this expression for both the outputs I0 and I1, we can draw the logic diagram. Then the logic diagram is, again, like in this example, you can see I0 S bar D. So it is going to be the select line S is going to be inverted up using the NOT gate. So you can see here where we have used the NOT gate for getting I0. Then for getting I1, you can see the expression is SD. So you can see here the input select line S, the second input D, they are basically fed to this AND gate, and we compute the I1. So in nutshell, the whole task or the logic diagram or the circuit implementation for this 1/2 demultiplexer is utilized here with one NOT gate and two AND gate. Now, if we talk about the 1/4 demultiplexer, now you can see here 1/4 mean there will be two select lines, let us say represented as S0 and S1, and there will be four output lines, let us say represented with symbols Y0, Y1, Y2, and the last one, let us say Y3. You can see here. And there will be the single input, let us say it is represented as I. So this input I is going to be sent on or routed on any of the output line depending upon the status of these select lines. So in this, just like 1/2 demultiplexer, we can write the truth table for this 1/4 demultiplexer. So you can see here we will have two select lines, let us say S0 and S1. Similarly, the outputs, let us say they are represented like Y0, Y1, Y2 and Y3. So depending upon the inputs, that is the status of the select lines, we will have the output line selection. So you can see when both the select line are low, then the output line selected will be Y0. This is the first row which is showing this working. Similarly, if we talk about this row, that is the last one, mean when both the select lines are high, then Y3 output is selected for sending input I. And these are the two combinations which will give an idea that how the output line Y1 and Y2, they are going to be selected for sending the input I. Now, following the truth table, we can write the Boolean expression or the logic expression for the 1/4 demultiplexer like this. Now let me start with Y3 first. As we all know, here it is the case what we are talking about for writing the expression for Y3. So following the truth table, you can see the select lines here are high. So it means Y3 output is selected for sending input I. Therefore, the expression for this one will be S1, S0 and I. Similarly, if we talk about Y2, then it will be S1, S0 bar and I. You can see here, this is the Y2. So it is the case what we are talking about. So you can see here in this row, S1 is already high and S0 is low. So this status is going to be written like this. Similarly, Y1, it will be S1 bar, S0 and I. And the last expression, that is Y0. So this is the very first row there in the truth table. Here the select lines are 0, 0. The values are 0, 0. For both the select lines, it is basically the low condition, but we have to select this Y0 as output. So the expression for this one will be S1 bar, S0 bar and I. So these are the four Boolean expressions we will have for this 1/4 demultiplexer. Now the logic diagram. You can see there will be two select lines. There will be four output lines, let us say represented as Y0, Y1, Y2 and Y3. And the single input, let us say represented as I. So these expressions you can see, first one is y3. If we talk about the y3, you just see here how y3 is basically designed. This is the y3. The inputs are S1, S0, and the third input I. This is the AND. So here the y3 is going to be computed. So you can see the four expressions are there, and these four expressions, they are, let us say, designed by using four AND gates. So if we talk about, let us say, y0, so let us say how y0 is basically implemented with the help of these gates. So again, there will be three inputs. We need S1 bar, we need S0 bar, we need I. So you can see here it is the I. Then both the inputs, they need to be inverted, and we know for inversion it will be with the help of NOT gates. Finally, S1 bar, S0 bar, and I. They will be fed to this AND gate fourth. Then we will have Y0 output line selection. Now, in the same way, with respect to the previous discussions, or we can design 1 by 8 as well as 1 by 16 demultiplexer. If we talk about 1 by 8 demultiplexer, then obviously, just like the previous approach, we require a single input I. There will be 3 select lines. Let us say they are represented like S0, S1, and S2. And there will be, you can see, we will have 8 output lines. So 8 output lines, let us say, represented like Y0, Y1, and so on to Y7. So we will have, and for 1 by 16, we will have 4 select lines, 16 output lines, and single input line. So one can simply design the 1 by 8, 1 by 16 demultiplexers very easily with the help of 1 by 2 and 1 by 4 design procedures. I hope this will give us a complete idea about the demultiplexer. Thank you.